I started.
Okay, thank you. Okay, again, so thank you very much. Welcome to this open science lecture on open science, or what it is and what does it really mean, organized by the Horizon Europe funded CHEK project. Before I continue, I would like to mention that this presentation is being recorded. So if you would like to put your camera off, or if you don't want to be in the recording at all, then please take your actions. My name is Jantien Stoter. I'm from the Delft University of Technology, and together with Francesca Nuarda, who's from the Open Geospatial Consortium, I'm coordinating the CHEK project. The CHEK project is working on developing tools and methodologies to increase the automation in digital building permit processes. And we do that with a consortium of 19 partners across Europe. The use and the development of open standards and also practicing open science is very important in our project to maximize the use of our results during and also after the project. And therefore, to learn more about this and to make sure we practice open science and we understand the principles, we have invited two experts to explain to us what are good open science practices and how to comply to the fair data principles. And since we think this lecture is useful for many others who need or would like to implement open science practices, we will make this lecture public. So I'm very pleased to announce the two presenters in this presentation. So first speaker is Tanya Yankelevich. I hope I pronounce this correctly. She is the Open Science Program Community Manager of Delft Technology, the Delft University of Technology, and I'm sure she will introduce herself more. And she will present about open science in general. And the second speaker is Bastiaan van Loenen. He's associate professor and also at our university, and he's chairing the Knowledge Center Open Data at the Faculty of Architecture and Built Environment. And he will explain more about how to use and generate open data, and specifically how to comply with the fair data principles. And after the two presentations, we will close with a Q&A session. So I would like to give you the floor, Tanya.
Thank you very much. Thank you for elevating me to the level of an expert. I wouldn't necessarily call myself that, but I will do my best to share my non-expert opinion and based on the experience that I have with open science so far. I am now sharing my presentation. Do you see it? Great. Now, I'm sharing the presentation, so I don't see the chat or anybody else's faces. So if there's anything, please let me know. Just unmute yourself and let me know. So I'm aware of what's going on, if there are any questions immediately, or if there's if you're not seeing the presentation or anything else, please let me know. Thank you very much for the introduction. Indeed, my name is Tanya Yankelevich. You did a great job with the name. I am the community manager for the Open Science program and the Open Science community at TU Delft, the Delft University of Technology. And in my role, I coordinate a lot of open science initiatives by the researchers or the support staff. I support a lot of initiatives with trying to find the right audience for them and the such, and generally try to advocate for open science practices. So thank you very much for inviting me to do this exactly here. I wanted to make a note that this presentation is, a lot of it is based on the original presentation by my colleague, Nicholas Dinster, who is the data steward, which is a very interesting position that we have in the Netherlands. And I know that not a lot of other European countries have that. However, we would advocate for it indeed, because it helps researchers with arranging their data-related practices in the right way. Very quickly, what we're going to talk about today, I'm going to start with why open science, with the open access to publications and reproducibility crisis as the background to the open science movement, what open science is, the different definitions, and the change in culture that occurred based on the crisis and that I mentioned earlier. And then I will give the floor to my colleague Bastiaan to do a little bit more specifics to talk about how to open science. So going back in time, how it all started. Open science is a very large term that covers a lot of topics, but it all started in 1991 with open access to publications. Right. In 1991, in the physics community, people started emailing each other their work to get feedback, to collaborate. And the email traffic was so high that at some point, Paul Ginsparg, at that point, a researcher and then further affiliated with the Cornell University, decided it was time to start a repository where people could share things openly in open access. And they called it Archive, if you see the way it's spelled here, right? Then the movement started with this need to provide free access to publications. It further was elaborated in the Berlin Declaration on Open Access to Knowledge in the Sciences and Humanities in 2003. The declaration was signed in English, and you can find it easily online, but the gist of it is we need to be able to share our knowledge publicly without a paywall. And that leads to a more active position the researchers started to take, not just on a policy level, but in 2011, Aaron Swartz, a political activist and scientist, decided that it was high time he did something to make publications open to the public without a paywall, and downloaded a lot of publications from JSTOR and made it publicly available through his affiliation with MIT. Now, that didn't go very well because once the university understood how much data was being made publicly available, they started a court case against Aaron Swartz. And unfortunately, in 2013, the case was closed because he committed suicide under the pressure. But the idea that he was propagating is information was the most valuable of currencies and a form of wealth no one should be deprived of, right? So again, going back to this open access to publications idea. It further elaborated into a number of policies before it became a national or international it turned into national international regulations. A lot of the policies started popping up here and there, and the Netherlands was one of the countries that was quite innovative and started doing things first. Here I have an example of 2016, the TU Delft policy on open access publishing, but other universities, of course, had similar policies in place across Europe. In 2018, a coalition of various universities decided it was time to act and agreed on a Plan S supported by the European Commission. Plan S was a guideline in which the idea was that any publicly funded research should be made publicly available free of charge. In 2019, this Plan S was amended with what is called the Taverne Amendment, according to the Dutch Copyright Act, Article 25 FA, in which it states that all scientific work, regardless of the restrictions by the publishers, should be made publicly available within a certain period of time. Now, this is currently being implemented. It was tested out. It was piloted in various universities in the Netherlands. It worked really well, and now it's being further implemented at TU Delft and other universities in the Netherlands. I'm not sure about the implementation of similar policies across Europe, but the Netherlands is a little bit advanced in that regard. So this was the open access to publications, the start of the open science movement. However, that's not all. In 2016, 15-16, there was a new development which we call reproducibility or replicability crisis, where Nature published an article in which, and not just Nature, of course, there's another study estimating the reproducibility of psychological science, where various different psychological findings in the psychological field were questioned because they could not be replicated, right? So if you look at the Google search and Google Scholar search, and you say reproducibility clinical trials from 2000 to 2011, that would be 11,000 results, whereas the number grows significantly higher in 2012 to 2013, because that's when people started realizing, hey, there's a problem. We can't replicate the results for various reasons, right? We don't know what it is, but the results are not reproducible. I have my own dissatisfaction with this. Back in 2016, I was reading a book by Malcolm Gladwell, in which he tries to use psychological theories to prove a point, and realized that all the things that I studied back in the day, when I studied psychology, were basically wrong, because they have been proven wrong in one way or another, because the data was falsified or because the results were not analyzed properly. So basically, a lot of people who did the same were quite angry with the fact that nothing that they studied, the theories that they used, can be believed in anymore. So that was coined reproducibility crisis. And if in the study published around that time, 52% of people thought that, yes, indeed, it was a significant crisis and we needed to do something about it. Now, this crisis of the reproducibility of results also came to the fact that there is data that is not published, but if it is, then it's not reproducible, right? So the data was the problem. How do we access it? In 2011, there was a report that found massive fraud in Dutch universities where, for various reasons, articles were published that which the data for which was falsified, right? And that was followed by a study in 2020, published, the results of which were published in 2022 by the EU, a scoping report on reproducibility of scientific results in the EU, right? So the international, European and international level, it has become a problem. They decided to see what the reasons are for falsifying data, what the reasons are for publishing studies that cannot be reproduced, and how the European Union on a policy level and national governments on their guidelines levels could affect the change in that regard, which led to a culture change. And here I mentioned the two agreements that I think were quite significant in that regard. In 2012, the DORA, San Francisco Declaration on Research Assessment, which was focused on funders and polishers, was signed. And in 2022, the COARA, the Coalition for Advanced Research Assessment, a very similar agreement, but focused on research institutions, was signed. The idea behind these agreements was we want to eliminate the use of journal-based metrics, such as the impact factors, for example, in funding, appointment, and promoting considerations. They wanted to assess research on its own merits rather than the basis of the journal in which it is published and the such, and also to capitalize on opportunities provided by online publications, such as relaxing unnecessary limits on the number of words, figures, references, and articles, exploring new indicators of significance and impact. So basically, focus more on the science part of things instead of how it affects your work, your promotion, your career prospects. At the same time, on a global level, the move towards open science was being made by UNESCO, which states that making science more accessible, inclusive, and equitable for the benefit of all is the idea behind open science, right? So in 2017, UNESCO published adopted recommendations on scientific science and scientific researchers. 2019 was open education resources, and 2021 it was generally open science. It didn't stop there, however, and with what is a little bit more relevant for the target audience today, right? The people who are involved in European research projects, the EU strategy for 2020 to 2024 states that open science policy is a priority for the European Commission and therefore a standard method of working under its research and innovation funding programs, right? And so you will see that, of course, in most of the applications, open science is a requirement. But how do we do this? What's happening, right? What is open science? Like I mentioned before, it's a rather broad concept, and there is no one definition. UNESCO, for example, identifies open science as open science increasing scientific collaboration and sharing of information for the benefit of society and science. It makes multilingual scientific knowledge openly available, accessible, and reusable for everyone. So it's a goal in itself, right? And it opens the processes of scientific knowledge creation, evaluation, and communication to societal actors beyond the traditional scientific community. Now, that's a definition. Another definition by the European Research Council is a mouthful, but what it comes down to is open science is by researchers through free access for more research and to maximize its usefulness, right? Other definitions include various things and focus on open science as a practice. So, you know, others can collaborate and contribute. Data, notes, and processes are available under specific terms with the purpose of reusing, reproduction, and distribution. Others say that open science is a transparent and accessible knowledge that is shared and developed through a collaborative network. So you can see the idea here, collaboration, making things available publicly for free. And what it comes down to is very often open science is seen not just as practices, but also as a movement to make scientific research, data, and dissemination accessible to all levels of inquiry in society, right? And the word society here is important because it's not just about researchers and research per se, it's about a global idea behind why we do research and who benefits from it. If we look Foster, I'm using quite a few quotes and materials here from Foster. Foster Open Science was the European funded project that officially ended in 2019, but it developed a lot of the terminology and a lot of useful resources for open science. So you can always go to the website and check them out. But Foster kind of did this tree where they tried to identify what open science means nowadays. So it's no longer just open access as it started. It no longer is, you know, making data available for reproducibility results. It's much more than that. It translates into the ambitions within the open science, European open science strategy, and it reads as open data, European Open Science Cloud. If any of you have ever dealt with that, that is a big thing in itself, trying to make a platform for everything and anything available within the EU. New generation metrics. So how do we measure, instead of using the impact factor, how do we measure the work of researchers? Future of scholarly communication, so making things open access. Rewards and recognition. How do we recognize open access practices? Because they're not a standard in the rewards and recognition framework. Research integrity and reproducibility of scientific results. Education and skills, and citizen science. Those are the things that the strategy mentions. How they practically translate into open science practices is open access. So articles are freely available on the internet, permitting any user to read, download, copy, distribute, print, search, or link to the full texts. Open hardware, which is slightly a bit more of a new concept. It's physical objects that are licensed in such a way that said object can be studied, modified, created, and distributed by anyone. Open methods, methods are available, details of research methods such as procedures, protocols, plans, notes, and interpretations. Open education, collective term that encompasses educational resources, tools, and practices that can be freely used in digital environment without any legal, financial, or technical barriers, right? Big thing right now in the Netherlands, a lot of money being invested in making sure that we do open education. And then fair comes into play. For those of you who are not very familiar with the term, I'm sure Bastiaan will talk a little bit more about it, but fair is usually referred to data and software, and it's an acronym that stands for findable, accessible, interoperable, and reusable. Right, so fair data and fair software, making it accessible so you can see it, reuse it, and redistribute it under conditions. And when it comes to software, there's open source in the same way. Citizen science is a bit of a new methodology, the inclusion of members of the public in scientific research to include citizens and communities in setting research priorities and engage them with the research process to allow them to also fully better understand what the research process is and believe in the value of it and the results. And ideally, the practice that we aim for is, if we call open data access publications, right? X stands for whatever else we mentioned earlier. I can see it, reuse it, and distribute X, and I know how X can be, the process that was followed. That's the idea behind open science. That's in one little formula, if you allow me the simplification. And I just wanted to end my presentation with hoping that you guys have questions, because of course I couldn't cover very much in the time allocated, but I just wanted to use this sticker that was developed as part of the open science communities, that open science is just science done right. So the idea is, in the end, we don't say open science anymore, we just say science, and that's how it's done. And with this, I would like to thank you and give the floor to Bastiaan for his very practical presentation on the implementation of open science.
Thank you very much, Tanya. So, Bastiaan, can you share your slides? And yeah,
sure.
It
This
works.
one?
Yeah.
I'll get
Give
rid
the
of
floor
you
to
then.
you. Yeah.
Thank you very much, and thank you very much also Tanya for introducing us into this nice domain of open science, which can also be kind of scary, apparently. People committing suicide for the sake of well, better society. Anyway, I'm going to focus on one practical aspect of open science, one aspect of open science, which is open data. What is it, and what does it really mean? Shantine already said I'm currently an associate professor in the Faculty of Architecture. I'm also directing the Knowledge Center Open Data, and I just realized that I'm more than half of my life busy with open access, open data, and especially in the domain of geographical information. At this moment, I'm I'm the scientific coordinator of an Horizon 2020 innovative training network, which is researching a sustainable open data ecosystem, where we want to arrive at a user-driven, inclusive, and circular ecosystem, which we currently do not have. So we are researching data and open data in this project from 15 different perspectives. If you're more interested, you can go to the link below that, opendataresearch.eu. But today I will inform you about open data, and I will briefly touch upon what open data is all about. But I also would like to explain a little bit more of a legal context. So I'll also go into the Open Data Directive and also into FAIR. What does it really mean, and what are the questions that are evolving around fairness? So let me start with open data. Many definitions around, and like open science, there is no one definition, but a very common definition which is accepted by many is a definition developed by the Open Knowledge Foundation, which is listed here. The data must be complete, the data must be primary, timely, so up to date, must be accessible, machine processable. The access must be non-discriminatory, so everybody should have access at an equal basis. The data formats should be non-proprietary, so open. The data should be license-free. Compliance must be reviewable, and especially the last one is interesting because the work shall be available as a whole and at no more cost than reasonable reproduction cost, which according to many is zero, but it's not explicitly written down in this definition of open data. This is a definition that was developed almost a decade ago, and right now, quarter to two today, there is this first meeting to update the open definition. So if you want to attend that meeting, it starts at quarter to two, where you can have an influence in what we mean by open data. So it's still a very up-to-date discussion, I would say. But in short, and also for this presentation for today, we consider the open data to be data without any restrictions in the reuse, and my interpretation of open data provided free of charge. If you have open data, and at this moment it's mostly open government data, but if you're doing open data, then you will see almost everywhere there is a significant increase in the data use. This is public sector information, our portal, which is offering a lot of geographical open data. You see an increase of, several thousand hits per year towards billions of hits today. This is open government data, but also in our institute, we developed, the group of Jan Tien, they developed a 3D model, building model of the Netherlands, which is openly shared with everybody in the world. And here you can see that, open science and open data can be used to track the reproducibility of the data. But you can also have a huge impact on society, because this model was picked up by a company and they did a nice visualization of the model, which showed the age of the buildings in a very appealing way. And my own daughter, who's in high school in the Netherlands, was one time coming home very enthusiastically, because in the geography lesson they're using this actually as an example of, well, how a city can grow throughout the years. So an open data research project, let's say, has resulted in a huge impact in society, because now our young ones are also getting familiar with developers in cities, but also with data science. So really nice to see that. Of course, open data is nice, but also be careful, because your data may interfere with other interests, and interests concerning the confidentiality of the data, because they were created for some commercial purposes. Of course, third-party intellectual property rights may be an issue which you have to take into account. Personal data, we discussed it already here in the recordings of this meeting. Very important. So if you have personal data in your research data, then it cannot be disseminated as open data. So be careful for that. And there are many other reasons you can think of. So open data, think before you act. That's on the research, the open data in general. I would like to focus now on the Open Data Directive. We have this directive since 2019. And initially, this directive focused on reusing public sector information, but the latest version also includes, broadens the scope towards publicly funded research data. So research data is defined here, documents in a digital form, other than scientific publications. Tanya already mentioned that these are available through open access, which is not the same as open reuse. So data which are collected or produced in the course of scientific research activities and are used as evidence in the research process, or are commonly accepted in the research community as necessary to validate research findings and results. So you can have a lot of discussion on what research data really means, also the interpretation of this, but at least research data, if they're publicly funded, are part of this Open Data Directive. And what does that then mean? So if research data falls under this definition of the directive, then the data needs to be reusable, free of charge available, and it should follow the principle of open by default and be compatible with the FAIR principles. And I'll come back to the FAIR principles in a minute. And the data should be as open as possible and as closed as necessary. And Tanya referred to that already before. An interesting aspect here is the directive refers to the member states to implement national open access policies. To implement these policies that I just mentioned before. So it can be very well that one country is implementing it in a different way than another country, which may imply inconsistencies in these policies. So if you want to adhere, let's say, to this this directive, then very much make sure that you are familiar with the national policies and try to align them. Also in the CHEK project, try to align them so that users will not be confused about what exactly is applying to the data that you are disseminating or distributing with them. Also on FAIR, the directive mentioned FAIR, and it has to be your research data has to be compliant with FAIR, but it doesn't define FAIR other than findable, accessible, interoperable, and reusable. So maybe they want you to make your data fair according to the FAIR Kinding principles by Wilkinson and colleagues, which is the basis for the FAIR principles. And you will find here that there's a lot of focus on metadata. So if you have metadata documented, in one way or another. It doesn't really specify whether it has to adhere to a certain standard or so. You are relatively fine, but you can have a lot of criticism on this fair guiding principles model because, for example, if you're looking at interoperability, it's focusing on technical, maybe also the semantical interoperability, but the legal interoperability is not addressed at all. So the data may be interoperable from a technical perspective, if you're following the FAIR guidelines, but from a legal perspective, absolutely not. To check, what do I mean? What do I mean by legal interoperability? For example, that a data set is disseminated with a certain license, and another data set is also disseminated but with a different license, that not necessarily the licenses allow you to do the same thing. That means that their data is not legally not interoperable. So that's an issue. It's not specified in the directive, and then it's up to the member states to implement FAIR. Well, and every member state may have his own stand here. So something you would like to try at home, probably. How is your research data doing? Is it findable? Is it accessible, interoperable, and reusable? Is it free of charge available? But then also a question you may have is, what exactly do you mean by FAIR? To whom should it be findable, accessible, interoperable, reusable? Should it be for my peers? Should it be for my parents? Should it be for someone else? You probably, based on the user group that you envision, you probably have a different answer for how fair your data is. So that's also a point of attention. Then that was the Open Data Directive from you as a data provider perspective. I think it's also relevant here to refer to the Open Data Directive, which is relevant for you as a data user. The directive focuses on public sector information. And if this public sector information is publicly accessible, so you can view it or otherwise can access the data, then also this directive says that the reuse should be required, which means that the data need to be available in open machine readable formats. There cannot be any legal restrictions. And in principle, the data should be available free of charge. Unless, and there is this nice rule, unless the public sector bodies are required to generate revenue to cover a substantial part of their costs relating to the performance of the public task. And that's still the case in many countries, many organizations in Europe. However, this free of charge unless does not apply to high value data sets. There is a special regime for high value data sets, which high value data sets are data sets that are assessed to have a very high socioeconomic value for the whole of Europe. Here's a nice definition of high value data sets, but in basics, in principle, these are the data sets that are most important for the well-being of our society. And for these data sets, there is a special regime, and it applies to 6 data themes. And the data themes include geospatial data, which is the domain I'm active in. Also observation environment, meteorological data, statistics, companies and company ownership, and mobility. If you want to check the exact details, because there are also data sets listed, I'm referring you to this implementing regulation, which has been accepted by the European Parliament last December and published in the official journal this January, so very fresh. So if a data set you would like to use in your research concerns a high value data set, that means the data set should be available in a machine readable format, accessible through an API, and if that's relevant as a bulk. And these data sets should be available free of charge. Of course, there is a transition period for 2 years, but let's say January 25, these data sets should be available free of charge for everybody. The High Value Dataset Act also rules that these datasets should be available under Creative Commons license or dedication. So in principle, and they're referring to this Creative Commons license because it's one of the most commonly used licensing framework in the world. You may be aware that there are a lot of other licensing frameworks around or licenses around. And also here it applies, please, if you're using a certain license, you prefer to use a certain license in your project, please use the same license throughout the project to make it very easy to understand for your users that the data that you are using is also from a legal perspective interoperable. So pick one of the licenses that are listed here, preferably the most open ones, and be very transparent also in how you are why you're using these data these licenses. Because that's my final slide. There's lots of open data around. There's also lots of interpretations around what open data exactly is. Also what open science exactly is. But in your project, please be transparent as much as possible, and also be consistent as much as possible in your interpretation, also implementation of open data and open science, because that's in the end what all matters, and that's what's in the end also going to result in a lot of reuse of your CHEK project results. That's in a nutshell what I would like to tell you. There's lots of literature available on this. These slides will be shared with you after the presentation, and there are some really nice links, including the link towards the meeting where the open data definition is being discussed, which is now. Thank you very much. And if there are questions, please let us know.
Thank you very much, Tanya and Bastiaan, for this very nice overview of the history and the background motivations of open science, and also about all the guidelines. And I see that we have some work to do in the CHEK project. But let us see if there are any questions from the participants. So maybe I have a question, because this lecture is about open science and you're focusing on open data. But in this project and also other projects that I'm involved in, software development is also a huge part of the project. So how does open science applies to software that's being developed in such projects?
Bastiaan, would you like to take this, or should I?
Please go ahead.
I think in the Open Science program at TU Delft, we generally treat data and software similarly. We have a similar infrastructure for it. So software should, if it's developed, well, we generally advocate for it to be open source, but especially if it is developed under the European funded projects, it should become open source. And by that, I mean, it's not just the code that should be available, right? We're talking about the minimum requirements and the actual implementation of open science. When the minimum requirements, a lot of the projects, what they do, they just dump data, dump source code somewhere. But in reality, you're supposed to write appropriate metadata. You're supposed to write the description of what, why, and how, so people can actually use the work that you've produced in their own work later on. So it's a little bit more work, but it's also more rewarding, because then you actually know that the work that you've done is not going to be just a one-off, but it's going to live on through other projects as well.
Okay, so this is according to the open science principles of TU Delft,
yeah.
But we have, for example, commercial partners in our project who also not get their work fully funded. How can they comply with the open science principle?
Perhaps Bastiaan has a better answer to this. I don't know all the legal details, but I do know that the idea behind it is, as open as possible, as close as necessary, is if you follow the steps from the beginning, if you do a data management plan, if you prepare things in advance, you know which parts can be shared and which cannot. So it's often that also not the full code is limited because of the IP limitations, but only part of it, right? So of course, if you have limitations, you have to follow them. But if you do the work in advance, you'll know which parts do not apply under these limitations.
Clear. Okay. Bastiaan, that's something to add? Or?
Yeah, well, so there is of course not one size fits all approach, and in the end, we all want to advance society. So, if you are not able to cooperate with companies because of open science principles, that may also imply that the nice results that you would expect from this cooperation will never be there. and that's also not something that we want. So there is no one size fits all in this.
Yeah, I
but
understand.
as Tanya was saying, so it's open unless.
Yeah, because I guess, yeah, so companies of course have also their interest to participate in the project with different business models than a university has.
Also, because some of the partners are from TU Delft, and I can't necessarily advertise this as a service for all, but because some of the partners are, you can always ask questions to the Open Science program. We have specialists who work on specific areas of open science. If you go to TU Delft/Open Science, you have all the contacts or all the information of people involved. I can put it in the chat as well. But if you have more specific questions, they would be the ones to help you go
Thank
through
you very
case by
much.
case.
Okay, I see a question from Peter.
Hello, good afternoon. I had a very interesting meeting and presentations. I had questions out in the open source licenses. Normally, or very often, it's not allowed to use it in closed source software. So it's open, but it's only open if you reuse it in other software that is also open. Is there a similar license or a similar thing for data? Of course, source code is also data, but just for pure data not being source code, that it can only be used, for example, in open source solutions or in combination with other open data.
Yes, there is, and that's the Creative Commons Share Alike license. You may have heard of it.
No.
So the distributed work, so the work that is building on the data set that's provided as open, the derivative work should be provided under the same conditions as the original work. So if the original work is provided as open data share alike, then also the new work should be disseminated under those conditions. So it's I will write it down in the chat.
Okay, thank you. And in principle, do you what license for the open source license would fit best? Because we are with commercial companies, would a license where it's allowed to use be used in commercial closed source solutions the best choice, or would a more restrictive open source license would apply? Do you have any advice there?
Also, there is not one size fits all. So this it needs to be a little bit more specific, maybe. But also here, as open as possible, and the Open Knowledge Foundation definition that I was referring to considers the use of this share alike license also open. While others say, oh, share alike, that implies a restriction in the use, so therefore we don't consider it to be open, and you need to have a Creative Commons 0 the dedication license instead of the share alike. So also there, what is open, what is not open comes back, but as open as possible is the way to go, and I would argue that the Creative Commons Share Alike license is the most closed license that you would be able to argue that it's still open science.
Okay, clear. Thank you.
Okay, are there other questions? So, Bastiaan, you also advised to choose a license that at least realize some kind of consistency over the whole project. And so I can imagine that it's a bit more complicated in this project, where you have also interest of companies to not open all the data and all the software, right? But that, I guess, that's also refers to the question that Peter had. But it's something that I assume that we have to look into a bit more, I guess.
Yes, I think so, and I'm probably also closer look into this definition of research data. Which was also interesting how this should be interpreted. But the most important part to start with is to make very transparent in what use conditions apply. So in the past, you had some people just publish something on the web without a license connected to it. So then everybody's in the blank. Nobody really knows what the conditions were. So that's the first step: make transparent what conditions apply, and preferably those are consistent. And then even more preferred is that they're all open.
Okay. Okay, so I assume that we will need some more of your knowledge in the future, but happily I'm someone who works at the university, so I can
We are right next door, yes.
Francesca, you have a question also.
Yeah, hello. I have a question on the open peer review processes, because we read in documents that it's recommended for open science and so on, but then we had to prepare to make some choices for a special issue proposal or something, and we were discussing if it could affect, for example, the quality of the review, and if it could be recommended or not, and how to proceed with respect to it. So what is your vision on that, and what are, in your opinion, pros and cons of open peer reviews?
Bastiaan, if you don't mind, I can go first, and then you can. I think open peer review is a very subjective topic, so there's no one way to do it, or one way to describe what the pros and cons are. Generally, there are various layers of open peer review, right? What stage of the review do you make open? For example, there is such a thing as preprints, right? I'm not sure if everybody's aware, so I'm going to explain. When you post your work before you submit it for publishing on an open access platform where others can contribute to your work already directly by commenting, basically making their comments open or closed, but still available to you, right? So that's the level of how open you want to go. You can make it available for everyone to see, and all the comments available to see, and who made those comments available to see, or you can close that, so make it available for people to comment, but only you see them. Then there is another way to do it, and that's if you don't want to do that, but you want to have an open peer review in a similar way you submit your public for a peer-reviewed article, a peer-reviewed journal. You agree that you will see who reviewed your work, and the reviewer would be not anonymous, but rather available. You will know who reviewed your work. Another layer of openness to add to this, you can make the review itself, after it's been done, publicly available, right? So there are various levels at which you can make it open or not. And it opens up, of course, the process opens up this issue of, oh, but what if I know who's reviewing my work? Could I potentially influence the review because I really need this article published? You know, could I just write an email because I know that person? We're all in the same community. We all know each other, you know, no big deal. Could be not, right? This could also happen with the closed peer review, right? The idea behind peer review generally is that you improve your work, which doesn't always happen when it's a closed process, because you just submit, if the article is not accepted, you submit it to another journal and kind of see where it lands. The idea of making your work, of improving your work before you submit it, so the preprints, for example, kind of speaks to that, right? So you're not doing it for the sake of, oh, it's a requirement, oh, I'm doing this because peer-reviewed articles or journals that accept them are more prestigious. You know, you can make your work more prestigious by opening it up for comments in advance. I know a lot of the people in our community, especially in the physics department, do that, and that has been proven a very effective way of improving their work before they even submit it for publishing. So there are different levels of openness when it comes to this, and there also, if you look at how people comment on the work, it's not always the most in the most polite way. Let's be very frank here, right? Some comments could be made into constructive criticism with just a bit of a tweak to the language, but because people don't take responsibility for it, because it's a closed peer review, they don't care, and that is not always does not always lead to the improvement of work, but rather a disappointment on the side of the person who submitted the article, right? By making it open, you kind of make people responsible for the things that they say, because their name is going to be attached to it, right? So there's my view on pros and cons, but like I said, it's a very subjective topic. Some people just don't believe in peer review anymore at all. Others don't believe in open peer review. Others think that it should be sometimes open, sometimes not. So it's a big question there.
So there's no standardized view on this yet. Maybe it will crystallize in the next years. Or...
Well, that's the hope, right? But I know that there are a lot of journals out there that are testing out different approaches. So some test out the preprint approach, some test out the opt-out option. So we have journals that are by default open peer review. And then when you become a reviewer, you have to opt out of this being open peer review and your name being listed. And there have been some issues there because people tend to not think about this. And then when they realize this and they think, uh-oh, I did not use the language that I should have if it's going to be open, then, you know, questions arise. So there are a lot of approaches that are being tested, but there's no definitive answer as to which works best. Let's hope that at some point we'll arrive to it. But there's also, I guess, benefit in diversity.
Yeah, it's indeed also requiring a change, a total change in society, right? Because also more than intentionally trying to condition the reviewer, maybe it's the author is a very important professor, and you don't want, you are a small PhD, and you don't want to argue against his work, or the other way around, you know, you're a beginner. So it's really like, how do you have an idea, or is there any theories out there how we can, as a community, as a scientific and wider community, support also this change?
There's also a question of whether we should, in fact, do peer review for the journals that don't publish open access, right? If we're advocating for openness, then we only review, because it's an additional work that you're not really getting paid for, not getting recognized for, another aspect of open rewards and recognition for open science. But perhaps we should just not do reviews for the articles that are not going to be open access, you know?
Yeah, good point.
Is there a list available somewhere? So is it public, or do you need to go through the pages of each journal to find out?
I have not had a list, but I'm organizing an event on the 18th of April, which will be streamed. So I could share the link, registration link with you if you're interested. It's going to be a panel discussion where exactly these issues are going to be discussed. What the end of peer review, the failure of peer review, what the open aspects are acceptable or not. It's a community event, so nothing huge, super major, but we're going to have a diversity of perspectives there to see what's what. So if you're interested, I can share the link afterwards, so you can.
Thank you very much.
Join. Yeah. For those in Delft, you can of course join in person, but yeah.
Or you can come to Delft to still join in person. Okay, are there other questions? No, then yeah, again, I really would like to thank you very much, Tanya and Bastiaan. So we are experts in very different other fields, so we really need experts like you to understand how we can comply with the FAIR principles, and also how we can make it the results as open as possible and as closed as as close as necessary. Okay, so I'm sure that we will get back to you. And yeah, I think we have to do some homework also in the project. So thank you very much. And
you're welcome.
Get back to you. Okay, thank you also for the audience.
Thank you, everyone.
Bye.
Thank you, everyone. Goodbye.
Thank you. Bye-bye.
Thank you. Bye.
Bye.